So today's lesson will be on fractions. Fractions, you can see from the questions we just solved on those ASVAB questions, you can see that there were a lot of questions in fractions. They require you to use them, to be familiar with them, to know how to deal with them. And we want to go over this because I want you to become comfortable with dealing with fractions. Okay? So
Okay.
let's talk a little bit about fractions. So, what is a fraction? A fraction is a part of something. Like when you want to express like a part of just a section of something, you use a fraction. So it's a part of something. For example, you can see the circle here. This circle is a whole, but has been divided into four parts. Think about the pizza. When you have a pizza, you divide a pizza into many pieces. So when you divide a pizza into many pieces, one part of a slice of pizza is a part of the pizza. And you can count it as a fraction of that pizza. So if this is a pizza with four slices, it's not usual for a pizza to have four slices. One of the sections here will be one part over a total of four parts. So for such, you're going to write your fraction as 1 over 4. But if you're considering three parts, it'll be three parts out of four, two parts out of four. Now, we have some examples here. We have examples of parts that are represented by shaded portion. The instruction says that write the fraction that represents the part of each figure that is shaded. Now, I'll do question 1 and question 2, then you can try. Question 1, we
Okay.
have the shaded. One part is shaded out of 6 parts. So my fraction will be 1 out of 6. So my fraction here is 1 over 6. Question 2, I'll have 1 is shaded out of 8. So I'm selecting one piece out of 8, one bar of chocolate out of 8 tablets of chocolate. So it's 1 over 8. Now, what will be this fraction? I want you to try this from 3, 6, and 9.
Okay.
You can just look and tell me for question 3.
Um, 3 out of 4,
Correct?
4 out of 9,
Correct?
mm, 5 out of 9.
Correct. Good, we can move from that. So, we want to write fractions now from real life situations. How can you generate fractions from a real life situation? Let's take an example. Before we go forward, I want to say something that's going to help you with fractions. Remember in the example of the pizza that I was talking about. Now, when I say, for example, that you take two slices of pizza out of a pizza with 5 pieces, your fraction is 2 over 5. Now, in that fraction, the unit of the denominator and the unit of the numerator are the same. You will not have a fraction that's correctly written with different units in the numerator and the denominator, except if it's defined as such. But usually, a properly written fraction will have the same unit in the numerator and the denominator. But in case of questions that we'll solve using proportion, we'll be able to use different units. But we use that just for relationships. But in a proper fraction, or in a fraction that will be doing a proper way of addressing fractions, fractions have the same unit in the numerator and the denominator. Now let's take a look at this. They say a foot contains 12 inches. One foot is 12 inches. And this you can also retain this. It's going to be helpful for you. 1 foot is actually 12 inches. Now, 5 inches is what fraction of 1 foot? Now, you will not say that 5 inches will be, the fraction will be 5 over 1. It's not correct. because uh, 1 watt, you say 1 foot, but it doesn't have the same unit with the inches. That's why it doesn't work. Rather, you ask yourself that the 1 foot is how many inches? It's 12. So your fraction will be 5/12. Make sense?
Mm-hmm.
Question 2. 47 cents is what fraction of a dollar? In $1, we have 100 cents. So 47 cents will be 47/100. That will be the fraction of 47 cents compared to a dollar. Make
Mm-hmm.
sense?
Yes.
Okay, you can try it. A pound contains 16 ounces. 9 ounces is what fraction of a pound? What do you think?
9/16.
Correct. A yard contains 36 inches. 23 inches is what fraction of a yard?
23/36.
Correct. 7 months is what fraction of a year? 7 months is what
Seven.
fraction of a year?
7/, oh,
No,
365.
same unit. You cannot say month over days or month over years. It has to be month over month.
Oh, month/month.
I,
What
are
is
you
it?
telling me you don't
One
know the number of months in 1 year?
12 months.
12 months.
So it's
Good.
7/12.
7/12. Very good. There are 100 centimeters in a meter. 6 centimeters is what fraction of a meter? 63, sorry.
63/100.
There you go. Good. Now from here, we're going to be looking at the 3 types of fractions. You can see that when we're solving the mock test that I sent to you, we use this. But I'm also coming over it just to make sure that everything is clear. The 3 types of fractions that we're going to be looking at is proper fractions, improper fractions, and mixed fractions. Now, for proper fractions, it means that the numerator of the fraction is actually going to be is smaller than the denominator. You can see here 1/3, 3/10, 7/9, 19. All these fractions have a smaller top numerator and a bigger denominator. It's like you're proper. Now, improper fractions are a little bit like SpongeBob. You know how SpongeBob has his big and very little legs at the top, at the bottom. You can see all the numerators here have bigger are bigger than the denominators. We have 3/2, 9/4, and 8/8. All these are improper fractions.
So you'll put 8/1.
Yes, it's an improper fraction. Now, a mixed fraction is composed of 2 sections, a whole number and a proper fraction. 1 and 2/5 is a mixed fraction or a mixed number. 3 and 1/2 is mixed. You can say it has a whole number and a proper fraction. A whole number and a proper fraction. Very good. Exercise. Identify proper, improper, and mixed fraction. Question 1.
Okay.
Is it proper or improper?
Improper.
Question 3. Is it proper or improper?
Mixed.
Ah, good. Question 7. Is it mixed or proper?
Improper.
Okay. Question 11. Proper or
Proper.
mixed?
Proper.
Proper. So you were not choosing from the options I was giving you?
If you're wrong, I'm gonna correct you.
Very good. Next, we want to reduce fraction. This is what I was telling you about in the exercise we were doing a moment ago. You have to learn how to increase and reduce fractions. This is so important to manipulate fractions, especially when you want to add, subtract fractions that have uh, different denominators. Learn to add and learn to reduce and increase fractions. Now, to reduce fractions, it's easy. It's easy when you already master what is greatest common factor. Do you know what's the greatest common factor?
Yes.
Perfect. Now, look at this example that we have here. We have 15 and 20. They say reduce 15 over 20. Now, what is the meaning first to reduce a fraction? When they say
Break.
reduce a fraction, you have to bring it down to a point that it has no more common factors between them, apart from one. There are no more common factors. That's you have reduced it to the lowest form. Now, between 15 and 20, are there common factors between them?
Yes.
What is the greatest common factor they have in common?
5.
5. So once you have their greatest common factor, you're going to say 15 divided by 5 and 20 divided by 5. You see that your answer will be 3 over 4. You've reduced it. Another example. Let's take the case of 48 divided by 64. Now you begin to see that as the numbers get bigger, it requires you to have a good understanding of the multiplication table. Now, the common factor between both of them here will be 8. But look at what happens when we divide this. 48 divided by 8 is 6. And 64 divided by 8 is 8. But if you look 6 and 8, they will still have something in common.
Mm-hmm.
They have 2 in common. So you divide it again to reduce it further. So you have 3 over 4. I'm sure this
Okay.
reduction makes sense to you.
Yes.
Let's try.
Okay.
Exercise. Question 1. 6 over 12 reduce the fraction 6 over 12.
3.
No,
Wait, 2.
no,
Oh, wait, 6.
no.
Could be 1 over 2.
Are you giving me the greatest common factor, or you're giving me the answer of the reduction?
Both.
Okay, give me the answer now. I did not know what you were telling me, so I did not hear you. So
1.5.
6 over 12 gives you 1 over 2.
Yeah.
Correct. Question 2. 32 over 36 gives you. You can write it down and simplify. You don't have to do it from your head.
Mm, Is it 12?
No. You mean the common factor?
Yeah.
No. 12 is not a factor of 32. You can break it down slowly. You don't have to do it directly. You can take, for example, 4. You can take 2. You can take something little and break it down gradually.
Is it 8? And then it'll be. Oh, is it 4? And then it'll be 8 over 9?
Yes.
Okay.
Good. Let's try 6. 26 over 39.
1?
That was good because if you see the factors of 26, we have 1, 2, 13, and 26. The factors of 39, we have 1, we have 3, because 39 divided by 3 can go. And you have 1, 13. You have 13 too.
Oh, so it's 13.
Mm-hmm.
Oh, just- maybe 2/3.
Correct. Correct. So you have to familiarize yourself with reducing fractions like this. Reducing them quickly, bringing them back up, reducing them. Now, increasing fractions is just a reverse of reducing them. You see how you divide by a common factor and you reduce it. To increase the fractions, you have to multiply by a common factor to increase it. Or to pick a number and multiply top and bottom, it increases it. Now, this technique is good, like you saw me doing just a moment ago, where you want to add or subtract fractions with different denominators. Let's take an example. Let's say you have 1 over 4 plus 1 over 32. They give you something like this. One student will find the lowest common LCM between 4 and 32. I say it's 32. And he's going to do it the normal way. But another way to do it is multiplying this by 8 and this by 8. This is increasing the fraction. I know that I'm multiplying by 8 because my 4 in the denominator becomes 32. So that means I'll have 8 over 32. From this, I can see clearly that my answer here is 9 over 32 without having to stress so much. That I've saved some time. Makes sense?
But you said, what is that? Is that a 1/32?
Yes, this is a 9 over 32
Oh, 9.
because this will be 8 over 32 plus 1 over 32. You add
Okay.
the numerators and you over the common denominator. So
Okay.
9 over 32. So this is actually quicker to compute fractions when you know how to increase and also reduce fraction. Okay. The next thing we're going to be looking at is converting fractions, or let's say raising fractions to higher terms. I think this is what we just spoke about right now. But I will not spend so much time on it. I'm going to take the opportunity to teach you this as a lesson on proportions. Let's look at this. I will not use the method here. I'll use another method.
Can we make it
The
bigger?
question, yes? What did you say?
Can we make it bigger? Can we see like that?
Better?
Mm-hmm.
Okay. So you can see here that question 1 says that raise each fractions to their higher terms by filling in the missing top number.
Number.
Now, there are many ways to do this, but there's one way I want to teach you because I want you to to start getting familiar with proportions. Remember the questions on proportions I was solving? I was saying like a quantity divided by another quantity is equal to a missing quantity divided by the other quantity. Remember that?
Mm-hmm.
Now, we have here 4 over 5 equals to something missing over 30. Now, to do this in fraction language, you have to figure out between the numerator, the two denominators. You can see that if you say 30 divided by 5, it's going to give you 6. Meaning that this fraction has been increased by 6.
24.
So to get the number here, it's just going to be 24. Now, you can do the same method for any other fraction, for all the fractions that you meet here. Let's try, for example, 2. You can see 2
Mm-hmm.
here. If you see 2, you can see that the fraction has been increased by 2 times 2. So that means the top
18.
should be 18, right?
Mm-hmm.
Another way you could do this is by saying that 2, or for question 2, is 9 times 20 divided by 10 is equal to the unknown. This is what I was doing when we were doing together. This will cancel with this. I'll have 9 times 2, which is 18. But it's okay if you can see also that the fraction has been increased or reduced by a certain amount to go quicker. It's okay to do that way too.
Okay.
Let's try again. 3. 3 says 1 over 16 equals to 1 over 18. It's equal to something over 18. Now,
3.
before you do this, let me explain to you when this is necessary to do this. This is necessary when the two denominators have nothing in common. Like when they have nothing in common, when you cannot divide them, you have to use this method. Look at what I'm saying. Let's take for example, if they give you 1 over 13 is equals to, let's say 4 over 13 is equals to missing over, let's say, 25. You see that to find the increment, you cannot say 25 divided by 30. Or you can say it, but it's not direct. You cannot see it directly. So it will be easier to say 4 times 25 just divided by 30, and you get your answer of the unknown. But if you can see it, that 18, for example, divided by 6 is 3, and you multiply the numerator by 3 to get the other side, it's also good. You go quick. So knowing how to move in different situations is also helpful. So question 3 was too easy. Let's move to something else. Question 4. What is missing up? Question 7, sorry.
14.
How many? 14,
4.
correct. 11, what is missing?
12. Right, 10, 15, 20, 25, 30, 35. 35.
How many?
35.
Okay, correct. Very well. I'll not spend more time on this. This is easy for you from at this point. Now, the next thing we want to look at is how to change from mixed to proper, to improper, or to whole, like to moving from one fraction to the other. For example, we have here 29 over 9. 29 over 9 is an improper fraction, correct?
Mm-hmm.
Now, if we want to change this improper fraction to a mixed fraction, how do you think we're going to do it?
Mixed.
You're going to have to divide, right?
Mm-hmm.
You have to do a long division. Or you can say that if you divide 29 to 9 people, each person will have how many? Each person will have 2. Then how many will be left? Because 2 times 9 is 18. So the amount that's going to be left is around 3, right? So you'll be left with 3 to share to the 9 people. This begins to form your mixed fraction. Now, for a mixed fraction, you have to always simplify the proper section, the proper fraction here. You reduce it. If we reduce, it's going to give you 1 over 3. Do you agree?
Yes.
Okay. So I have changed this fraction from an improper fraction to a mixed fraction. Now, to move back from a mixed fraction to an improper fraction, this is what you do. You do denominator times the whole. The answer you get, you add it to the numerator, then divided by the denominator. For example, here you're going to say 9 times 2 plus 3 divided by 9. 9 times 2 plus 3 divided by 9. So this is going to give you 9 times 2 is 18 plus 3 is 21 divided by 9. Here you have 2 times 3 plus 1 divided by 3 is equals to 7 over 3. Of course, if you reduce this fraction, you get this. If you reduce 29 over 9, you get 7 over 3. So it's the same thing. Right, Shaila?
Yes.
Very good. Let's try. I want you to
Okay.
reduce these fractions from question 12 to question 14.
Okay.
Not reduce, but to convert them to mixed fractions, I meant to say.
Mm. So number 12 is 5? Or do I like put 5 1/9?
No, it's just 5. Because 45
Oh, just
divided by 9 is 5.
okay.
If you say 45 and 1 over 9, you're telling us that when you share 45 to 9 people, 1 will be left to give to 9 persons, which is not true.
Oh, okay. 14?
For
Do
question,
14?
no, 13 first. Are you done with 13?
It's 1.5. I mean 7.5.
How many?
7.5?
Okay. 7 and 3 over 2. Yes, that's correct. 14.
Okay. Five, 6, 7, 8, 9, 30, 31, 32. Two and 2/3.
That's 2 and 2/3. That's 24. 24 plus 36. 8. 8 over 12. Yes. 8 over 12. 4, 2, 4. You're correct. Correct. You know, when you're just leaving from school, your brain is as sharp as a Japanese or a Chinese knife. That is good. Okay. Now, next exercise, question 10 to 13. We're moving from mixed fraction back to proper fractions. Mixed fractions back to proper fractions.
Okay. Which one?
Question 10.
Um, 31.
No, it's a fraction. You're going to have 10 and 1 over 3. 10 and 1 over 3, you have to say 10 times 3 plus 1 divided by 3.
10
3 times 10 is 30, right?
30, and then you add 1.
Plus 1, yes. 31 divided by 3 to get a fraction.
Oh, okay. So then after I get the number, then I divide it by the denominator.
Mm-hmm.
Okay. So like 10.1?
No. The answer you're supposed to give it as an improper fraction, which is 31 over 3. It's correct.
Oh, 31.
Yes. Well, the instruction says change each mix to an improper fraction, not to a decimal.
Okay. 12.
Wait, your answer here is 12? Yeah, do 12.
Well, no, yeah, do number 12. 55, 56, 57. 57 over 5.
Correct. 13.
13 is 50, 60, 60, 40, 49, 50, 51, 52, 53. 53 over 12.
Correct. Question 14.
14 is 68, 58, 59, 57. 59, 56, 57, 58, 59, 49, 55 over 8.
Correct. Very good. Now, the lessons that follow this will be addition and subtraction of fractions. The reason why I want us to go through this today is because tomorrow I want us to focus on applying the knowledge into solving a real question on fractions. So, to go past this, you have to learn how to add fractions, to subtract fractions, to divide fractions, and to multiply fractions. I know that you're familiar with a lot of this already, but let's try it. Let's try this exercise. We're going to try it directly on an exercise. I don't have to teach you this. I think you know already a lot of this. But let's see how you do. Let's try question 1. 2 over 9 plus 3 over 9.
5 over 9.
Easy one. Let's try question 8. 2 over 15 plus 7 over 15 plus 4 over 15.
Will be 6. 14 plus 14. 13 over 15.
Correct. Go further. Question 11. 4 and 2 over 3 over 5 plus 3 and 4 over 5.
7, no, 8, 1/5.
Correct. Nice one. 12. 6 and 3 over 10 plus 8 and 6 over 10.
6 plus 8 is 30.
No calculator. No calculator. No calculator.
Not 6, 14, 6, 7, 8, 9. 14, 9 over 10.
Correct. This is so easy. Okay. Subtract the following. Question 8.
Question 8. Mm. 13 over 24. It's not 13. Is it 10?
Look, 3
Oh, wait,
minus,
12. Yeah, 12 over 24.
correct. Question 12. 10 and 5 over
Mm.
8 minus 4 and 5 over 8.
That would be 6.
Correct. That was smart. 7 and 8 over 9 minus 6 and 5 over 9.
139.
Yes, but reduce the fraction. 1 and 3 over 9. You have to reduce the fraction. This is what you said. 1
1.
and 3 over 9. You have to reduce the fraction further.
Oh,
Divided by 3. Divided by 3. So 1
oh,
and 1 over 3.
1 over 3.
Yeah, 1 and 1 over 3. Good. So that's addition and subtraction of fractions. Uh, this is a little bit a step further because all what you were doing above was so easy because you were dealing with the same denominators. Now, if they change the denominator, adding changes a little bit. For example, let's try question 3. Question 3 says 7 over 8 plus 3 over 4. Now, you can also use the method I showed you in bringing the numerator to the same, bringing the denominator to the same as the other fraction to solve it. Try this and see what you get, and let's see what you get.
Wait, how do you, so always the biggest number stays?
Hmm?
In the denominator, the biggest number always stay or the smaller one?
The bigger one is easier because you're going to be increasing the fraction to look like the bigger one. The bigger one stays.
Will be 1.
You're allowed to write down. Don't try to solve everything in your head.
1.5.
Okay?
Uh,
1.5?
1.
Do you think if you multiply 3 times 2, 6, 6 plus 7 is 13 over 8? Look, I multiply this by 2 and this by 2. I'm increasing the fraction, right? So I get 7 over 8 plus 6 over 8. So this gives me 13 over 8. This is my answer. If I'm giving my answer in improper fraction, when in main fraction is 1 and 5 over 8.
Okay, okay. No.
Make sense?
Yeah, that's what.
Okay, fine. We're going to take a break here for today. I see how your brain is slowing down already. But I would like to assign you some work for tomorrow. Is that okay?
Yes.
This is what I want you to do. Since you already have this document, I want you to go to page 36.
36.
Yes, 36 of this document. Oh, wait. Rather, I want to correct what I just said. Go to page 30.
30.
Yes, your assignment is to solve the 15 questions on page 30 and 31. Can you see page 30 here? This page?
Mhm.
Yes. This is on addition and subtraction of word problems. So you have to
So
solve.
solve 1 through 8, or do those 4 questions?
No, 1 to
All of them?
15. 1 to 15.
Okay.
This is the only thing I want you to work on before we meet next time. These 15 questions.
Okay.
Yes, it's basically applying what we just did. And next time we're going to go over division and multiplying and applying again. Very good. So I'll send you a lesson request for tomorrow on Super Prof, and you just have to approve it. That work for you?
Okay.
Perfect. Okay, Charlotte, thank you for attending the lesson. This lesson today, you have the possibilities of reviewing it if you want to rewatch the lesson just to review the lesson. I always record my lessons in case the student requires it for revision. You just need to ask, and I'll send you the link so you can review it. Okay?
Yes.
Thank you. See you tomorrow then.
See you tomorrow.
Take care.